Hello and welcome to the demonstration video of the Coltraco Portalevel MAX PLUS, working on a 45 kg CO2 cylinder. I will be demonstrating the Portalevel MAX PLUS together with the Portasteele CALCULATOR, which converts the liquid level height found using the Portalevel MAX PLUS into an agent weight that can be compared and verified to the actual agent weight that's printed on the cylinder. The temperature of this cylinder is measured using the IR pocket thermometer, which is supplied together as standard with Portalevel MAX PLUS. Place the thermometer a few centimeters away from the cylinder, press and hold the measure button, and it will tell you what the temperature is. The temperature of this cylinder currently sits at 13.8 degrees Celsius. To begin your test, ensure a strip of ultrasound gel is applied from the top to somewhere around midway of the cylinder. If ultrasound gel is not available, you may use a spray bottle to ensure that the surface of the cylinder is wet. To start your measurement, ensure the sensor is connected to the main unit. Place the sensor a few centimeters below the shoulder of the cylinder, ensuring that the surface of the wall is flat before you take a measurement. And take a note of the digital readings in your mind. The first digital reading here, position 1, is about 1180 or 1200. Move the sensor in steps of a few centimeters and keep taking a note of what the digital readings are. It's 1500, 1100, 2400, 2500, 800, 800, 500. So as you can see, as I start to make my way down from the upper section of the cylinder to the lower section, the readings have dropped. I'm getting about 1200 to about 2400 in the upper section, and then it dropped to about 800, 800 and 600. So once you've passed this point, and you've passed a few low readings below or a few high readings above, you have identified a position where the readings change significantly. Now, move the sensor up to a position where you get your average high value in your high reading region. In this cylinder, my high reading region is found at the upper portion of the cylinder. So I'm going to place the sensor back in the upper portion of the cylinder, bearing in mind what my average high reading is. Now, when I did the initial scan at the beginning, my high reading ranged from about 1000 to about 2400. So an average high reading in this case will be somewhere around 1500. So I'll move my sensor around the upper portion of the cylinder until I locate this average high reading, which is about 1500 in this cylinder. Once I'm confident that I found the average high reading, I can go ahead and press calibrate. This is my average high reading, about 1500 or 1600, and I'm going to press calibrate. Once calibrate is engaged, the display would change from the digital readings to gas, and you would also notice that the bar graph would fill completely. Now, you may move the sensor to the position where you found your low readings, and the display should change from gas to liquid, and the bar graph would also disappear. In this cylinder, the upper portion of the cylinder was where I found my high readings, and the lower portion of the cylinder is where I got my low readings. So, I will be moving my sensor down in steps towards the low readings, which is at the bottom. I'm going to move my sensor down a few centimeters. Still says gas, gas, liquid. Once I've hit the liquid level, should move my sensor down a few more positions, maybe another 1 or 2 more positions to confirm if it is indeed the liquid level, where it would change from liquid, liquid, liquid. So you would get a number of liquids below that. This is to confirm that that is the actual liquid, the liquid portion. So I move it down once, it's still liquid. I move it up one more time, and it should still say liquid. So it's gone liquid, liquid, liquid. So I've got the liquid 3 times. So I'm certain that this portion and below is all liquid. So I move my sensor up in steps until I find the exact position where it changes from liquid to gas to liquid. The exact position represents the boundary of the gas-liquid interface, and that is where I want to be looking for. Still says liquid. I'm going back up until it turns to gas. Now it's turned to gas. I'm going to move the sensor down slightly until it changes from gas to liquid. You can see that the gas is slowly trying to change to liquid. Move it down ever so slightly again, and it should change to liquid. So if I move it up slightly, it will go back to gas. Still in liquid. I'm just going to inch it up slightly again, gas. Down slightly, it should turn back to liquid. The exact position where it changes from gas to liquid is your exact liquid level. Now it's in the liquid. So this is the exact position where it changes from the gas to liquid, and I'm happy that this is my liquid level. So I'm going to go ahead and disconnect my sensor from the main unit, and I'm going to go and take the measuring tape to measure the liquid level on the cylinder. Just be careful that the sensor doesn't move. And I'm going to take the measuring tape and measure the height of the sensor. The sensor has identified the liquid level at 101.8 centimeters. So I'm going to go ahead to my Portasteele calculator and put 101.8 centimeters. I've already created the cylinder record here, 45 CO2 green. I'm going to press the info button so you can see what my cylinder details are like. I'm going to put what I've measured, which is 101.8 centimeters. 8 centimeters, and the temperature was 13.9 as measured at the beginning of this video. And the calculator agent weight in this case is 45.46 kilograms based on what I've just measured, and I will add the record details. Serial number, I'll just put 1234, and the printed field weight, printed field mass, is the weight that's printed on the cylinder, which is 45 kg. So save this record and it'll go at the bottom. So you can see the record 1234 is just taken here, 101.8, 45.46 kilograms, and the weight difference is 1.03%. So the combination of the Portalevel MAX PLUS and the Portasteele calculator allows you to locate the liquid levels and convert it to agent weight to an accuracy of 1%, which is highly accurate. I hope this video showcases how the equipment is used, and if you have any questions, please feel free to contact us. Thank you very much.